system of these three rods, thin rods. These are three thin rods, each having a mass m and length l. So obviously they are making an equilateral triangle over here. We are supposed to find moment of inertia of these three rods about this axis, that is about zz dash axis. This is we have to find out. Let's see how we can find out the moment of inertia of these three rods about this axis. So one thing is sure, that is if you have to find the moment of inertia of these three rods about this axis, so somehow if you find the moment of inertia of this rod about this axis, this rod about this axis, we can find the moment of inertia of this rod about this axis, this work is done. Then we can go to this moment of inertia of this rod about this axis, this work is done, and then moment of inertia we find of this rod about this axis. We add the three moment of inertia and we can get the moment of inertia of this system about this axis. If we take this moment of inertia of this rod about this axis, is obviously whether you say moment of inertia of this rod about this axis or you say moment of inertia of this rod about this axis, once again the axis is passing through the end and perpendicular to length. So moment of inertia of this rod about this axis is ml square by 3. So moment of inertia of this rod about this axis is also going to be ml square by 3 only. So moment of inertia of this rod about this axis, that is if we say it is going to be ml square by 3. Its job is done. Of this rod about this axis, don't get confused with this angle. So this is once again, this rod is perpendicular to this length. Length is it is at angle of 90 degree. So how the mass is distributed about this axis is still ml square by 3. So plus ml square by 3. So these two work is done. Job is done. Now we have to find the moment of inertia of this rod about this axis. So how to find that moment of inertia of this rod about this axis? For that we can use the parallax theorem. We know the moment of inertia of this rod about this axis is ml square by 12. That is ICM. We know ml square by 12. And we have to find the moment of inertia about this axis, and these two axes, they are parallel to each other. So we can use the parallax theorem. That is ml square by 12. It is going to be ml square by 12 if we say about izz dash. If we talk only of this, work is, the job is done. Of this is ICM plus, if we take this distance as x, plus m into x square. So this is going to be moment of inertia of this rod about this axis, of this rod about this axis. Now what is this x? So we know that is this is equilateral triangle, so this is going to be 60 degree. So this is going to be 30 degree. This is 60 degree. So obviously this is going to be 90 degree. It was equilateral triangle, so this is 60 degree. Half is 30 degree, so this is 90 degree. So if this is L, so this is going to be L cos 30. So x is going to be L cos 30. We can replace by L cos 30. So it is going to be m L square by 12. That is, for this we can use the parallax theorem, plus m L cos 30 square. We can add this and we can get the answer.